Access to clean water is a basic human right, yet 2.2 billion people lack safe drinking water. Contaminated water, often harboring dangerous bacteria like E. coli, fuels widespread illness, threatens food security, and undermines public health on a staggering scale.
This is why we started our mission, to ensure that access to safe and drinkable water is no longer a privilege, but a fundamental human right. We are Green Current, and our innovation is called Micro-G Clean. We are thrilled to present it as our entry for the 2025 Conrad Water Challenge.
Micro-G Clean is an affordable, accessible, and eco-friendly system designed to tackle harmful bacteria in water. Our mission is to provide long-term solutions to make bacteria-free water more available, consistent, and sustainable.
We created a CAD of our Micro-G Clean unit to obtain a visualization of what our product would look like. We have a shell for the structuring and different components that we can individually create and modify to fit our unit in the best possible way. In the center is the Petri dish support structure with the lens and camera mount above it. Our outtake is located in the corner above a hole in the base of our shell with a coupling for the outtake tube and a servo for the valve. We also have mounting points for the Raspberry Pi and a battery inside the shell.
Now for the software side, we first needed data to create our detection model. To collect data, we rehydrated an E. coli sample and took pictures under a microscope. Ending at around 133 images, we uploaded the images and created a data set in RoboFlow, where we annotated the images. Splitting the pictures into train, test, and validation sets, we used a YOLO V8 model to train our machine learning model, ending with a model with accuracy of 75%.
With the research side, we found that Chlorella vulgaris was the most common form of microalgae, and so to figure out how much to use, we decided to purchase a Chlorella vulgaris starting kit to grow ourselves. Once the microalgae bloomed, we created 5 different ratios of algae parts to the E. coli sample parts: 1:1, 2:1, 1:2, 3:1, and 1:3.
After letting each one grow under light for around a week, we found that a ratio of 2:1 parts to both grow and block the bacteria the best. Concluding our question and also telling us, based on what the AI detection detects, we should release 2 times the amount of microalgae.
Together, we can make bacteria-free water accessible to everyone, everywhere. Thank you for your time, and we hope you'll join us on this journey to change the world, one drop at a time. Here is a physical demonstration of how the key components of Micro-G Clean works. Starting off with the brains of everything, our microcontroller. This is a Raspberry Pi Model B, and this will be connected to our water pump, our camera, and servos, along with any other electronics needed to power everything. Additionally, code and our custom-trained AI model will be put into here, allowing a quick real-time detection. Moving on to the water motor. Currently, it is connected to a battery just for demonstration purposes, but when connected, we can see the water flows out smoothly and efficiently, allowing our Petri dish containing the water sample to also be filled up quickly. Next up, moving on to our 3D printed parts, all of which are key components and also modular. Each one serving its own purpose, with the black one holding the Petri dish and thus the sample water, this one holding the microscope, a 10 times zoomed objective. And then lastly, this camera mount, which holds the camera and goes right on top of the lens. This allows for our camera to see through the objective and into the sample water that would be placed there on a microscopic level, which will then be attached into our Raspberry Pi for quick real-time detection. Lastly, moving on to our servo. While it is not currently 3D printed, This is what will be controlling whether or not the Petri dish water stays in or out of the dish. This was a quick demonstration of how our physical prototypes work.
Good,
No,
but 2
turn that
minutes.
off. 2 minutes?
Yeah.